አሁን የምናየው application of integration ነው። one of the applications of integrations is area. area normally regular shaped ከሆነ like square, rectangle or triangle በቀላሉ ዳይሜንሽናቸውን በመጠቀም ኤሪያቸውን ማግኘት እንችላለን። in case of irregular shaped bodies like curves ኤሪያቸውን በኢንቴግሬሽን ነው የምናገኘው። ስለዚህ የመጀመሪያውን ኬዝ እኔ area between a curve and the x-axis. in this case vertical strip ወስደን ቤዙን a very small differential distance x heighቱን ደግሞ y ብለን y is a function of x ስለዚህ the integral of f of x dx from a to b will give us the area. ሁለተኛው ኬዝ ደግሞ area between a curve and the y axis the same way ሆኖ ግን xን as a function of y ገልጸን with respect to y ነው ኢንተግሬት የምናደርገው። and area between two curves ደግሞ in case of a vertical strip ወስደን the height becomes y2 minus y1 and the base becomes a very small distance differential x. y2 minus y1 ማለት the function of the first curve minus the function of the second curve. So the integral of g of x minus f of x from a to b with respect to x ማለት ነው። with respect to ym the same way horizontal strip ወስደን the base becomes the x2 minus x1 which is the function of the first curve minus the second curve. ከዛ ኤሪያውን ኢንተግሬት በማድረግ with respect to y ማግኘት እንችላለን ማለት ነው። ስለዚህ as a clarify ለማድረግ እነዚህን ሁለት ኤግዛምፕሎች እኔ the first one is የመጀመሪያው ኬዝ ነው። simply vertical strip ብንወስድ እዚህ ጋር our differential area becomes the height which is the function y multiplied by the very small differential distance x. So this is equal to y ማለት f of x which is x square dx is equal to dA. So integrating both sides will give us the area from 1 to 2 of x square dx. This is equal to x to the power of 3 over 3 from 2 to 1. This is equal to 8 over 3 minus 1 over 3. So the final answer is 7 over 3 square units ይሆናል ማለት ነው። In the case of b it's the area between two curves. ሶስተኛው ኬዝ ማለት ነው። either horizontal strip መውሰድ እንችላለን vertical strip መውሰድ እንችላለን። in this case ግን horizontal strip እንውሰድ። The differential area of this horizontal strip is equal to the horizontal distance which is x2 minus x1 multiplied by the differential distance in the y direction which is dy. This is equal to the square root of y which is the first function minus y square. dy is our differential area, so integrating with respect to y will give us the area. Integral of the square root of y minus y square dy from 0 up to, if x is 2 then this is 4, from 0 up to 4. Evaluating the integral መጨረሻ ላይ 16 over 3 minus 64 over 3 minus 0 ይሰጠናል which is minus 48 over 3 ግን area ስለሆነ it's the absolute value or it's the positive value ስለዚህ 48 over 3 square unit ይሰጠናል ማለት ነው ፋይናል አንሰሮች። በመቀጠል volume of solid of revolution የሚለውን እናያለን። it has two cases. የመጀመሪያው when the solid is rotated about the x-axis, ሁለተኛው ደግሞ when the solid is rotated about the y-axis. So for the first case እዚች ጋር ለወሰዳት strip our differential volume is pi r square times height for any cylinder ነው ተብሎ assume ስለተደረገ in this case heightaችን is the differential distance x and radiusaችን ደግሞ from the x-axis up to the function which is y. ስለዚህ substitute ካረግን በኋላ integrating both sides with respect to x will give us our volume pi is a constant ስለዚህ ብቻውን ትወጣለች። the integral of f of x the whole square with respect to x from a to b will give us our volume of the solid of revolution. about the y axis the same concept ነው የምንጠቀመው። ሆኖ ግን with respect to x የነበረውን with respect to y እናደርገዋለን። ስለዚህ በዚህ መሰረት አንድ ኤግዛምፕል እኔ find the volume generated by y is equal to the square root of x between x is equal to 0 and x is equal to 4. ስለዚህ dv is equal to pi r square times height ነው ተባብለናል። our radius in this case is the square root of x. ስለዚህ the square root of x the whole square is x and our height is dx. integrating both sides between 0 and 4 ነው የሚለው between x is equal to 0 and x is equal to 4 ነው የሚለው። ስለዚህ ከ0 እስከ 4 ነው ኢንተግራላችንን ካልኩሌት የምናደርገው። our volume is equal to pi is a constant times x square over 2 from 4 up to 0. this is equal to evaluate ካረግን በኋላ our final answer 8 pi ይመጣል cubic units. ቀጣይ application of integration arc length ነው። let's say we have an arbitrary function f of x on the xy plane. ከዛ ይሄንን arbitrary function at some point ዲስታንሱን ማወቅ ከፈለግን የከርቡን we will take a differential right angle triangle over here እዚህ ጋር እናወጣታለን። ከዛ the y discrepancy dy the x discrepancy ደግሞ dx ከዛ arc lengthችን differential l ቢሆን very small distances ስለዚህ ይሄ በጣም very small ስለሆነ we can consider it as a right angle triangle ስለዚህ we can use Pythagoras theorem. the differential distance l square is equal to dx square plus dy square. ከዛ እዚህ ጋር ይሄኛውን ኤክስፕሬሽን የማይቀይረው over dx square times dx square እናደርገዋለን። ከዛ dl the square root of 1 plus dy by dx the whole square ማለት the derivative of y with respect to x the whole square ማለት ነው። ስለዚህ ሌንግዛችንን with respect to x ኢንተግሬት በማድረግ ማግኘት እንችላለን from a to b or ደግሞ as an option with respect to y ኢንተግሬት በማድረግ dx by dy-ን ኢቫሉዌት አድርገን ስኩዌር አድርገን with respect to y ኢንተግሬት በማድረግ ሌንግዛችንን ማግኘት እንችላለን። ስለዚህ to clarify and practical የሆነ ኤግዛምፕል እኔ find the distance on the graph y is equal to 2x from x equal to 1 to 2 ነው የሚለው። ስለዚህ ከርቫችን this is y axis and this is x axis ከርቫችን ይሄ ቢሆን from x is equal to 1 to x is equal to 2 find the distance ነው የሚለን። ስለዚህ our length is equal to the integral of the square root of 1 plus the derivative of 2x with respect to x is 2 square is 4 with respect to x from 1 to 2. this is the integral of root 5 with respect to x from 1 to 2. the square root of 5x from 2 to 1 this is equal to 2 root 5 minus root 5. so finally our length becomes root 5 units.